Okay. Hey, everyone. This is live app review 17, maybe. We're going to talk about profiling gas costs on NEAR Protocol. So we're going to look at a few different ways that we can measure different transactions. Specifically, we're gonna be measuring against tests that are running with Jest against our own testnet. So it's a very real, very practical example. So I'll go ahead and share my screen. Hang on one sec. Having trouble sharing my screen. All right, so just gonna share my screen now. All right, so you should see my IDE. Yep, okay. So basically, what we're gonna do here is I'm in a project called the Fungible Token Launcher. It's just a scaffold, like boilerplate example of basically just launching a fungible token contract, minting a bunch of fungible tokens, sending fungible tokens to, I'll make this bigger, sending fungible tokens to some users. I use as well the guest account flow. So like you can create a virtual or guest account that exists only in the context of the application or the application smart contract, and they can have fungible token balance. And then at some point in the future, they can upgrade their account, which would make it a real NEAR account, and the fungible token balance is preserved. So it's like, it kind of like this seamless onboarding, super simple onboarding. Let's say you have an app and you don't want all your users that you're inviting to your app or inviting to your, even just a web page, because they clicked like a link for a contest or a giveaway. You don't want them to have to, go and, get crypto, install some wallet, install an extension. You just want them to basically claim the tokens. This would be your way to do that. So this is called the FTLauncher. It's actually on github.com/near-apps/FTLauncher, but I'm sure you'll find that. I'll put it in the show notes. So I'm doing what's called test deploy. So what it does is it compiles the Rust contracts, and then it's going to start a new deployment to a new developer account on testnet. And then it's going to start to run through all of these tests. I'll actually open up, it's actually running this file right now. So what this does is it just sort of runs through, it creates an account for Alice, it creates an account for Bob, it runs through, it gives everybody tokens, checks balances, makes sure that they can send tokens to each other, blah, blah, blah. So it's doing a lot of this stuff. But what you'll notice is, so the tests are passing, and that's a good thing, right? There's not enough tests. Like there should be more, but I'm working on it. What you don't see here though is how much do these fungible tokens cost? So that's the topic of today's video. So let's drill into these costs, and I'll show you how I'm approaching this. So I have a different test here. It's called profile.test.jest, and it's a little bit lighter weight than the other test. And then I have an additional file here, which is just a bunch of helpful JavaScript. So what I set up for myself, and again, your approach may differ from what I've done, but what I set up for myself is just some useful in-memory sort of objects that I can store certain pieces of information, so that when I go through and I write my tests, here's an example of testing the claiming a drop. So like a social token drop would be like some amount of social tokens that somebody could claim if they have a particular link, for example. So claiming a drop, what I do is I've set up my profiler so I can call just set a mark. So basically set a marker on an account. So this is an account that I want to profile for how much gas is being burnt or used for storage or whatever. So I can set a mark and then I can get the burn. So what does get the burn mean? It means get the tokens that are burnt. Here, similarly, for a different contract, I have a couple of different accounts that I'm working with here. For a different account or the main sort of fungible token contract, I set a mark, and then I'm concerned. I want to measure the burn and the storage use. So when I create a guest account, in this smart contract, just this is just an example. When I create a guest account in this smart contract, I actually insert a record into this lookup map here. So I insert a public key which references an account ID. Now, what does that do in the context of the smart contract? It stores data, right? So it uses up some storage. So that's why here I have set the mark, and I want to get not only the gas burnt for putting the data into storage, but I do want to get the total storage that is being used in that operation. So that's what these are going to return for me. And at the beginning, I have a thing called start recording. So I have like start recording, stop recording, you know, things like that. So you can basically do something like this. You can get the costs. So get costs just prints it out in a nice human way. So let's take a look at what all this looks like just so that we know what we want, but like we know what we're expecting, right? So once again, there's sort of like, you know, start recording gas costs. There's you know, set a mark. Now record the burn or record the burn and storage, and then there's the last function, which is get me the costs. So let's take a look here. Oh, it's going to take a second because it's measuring 10 transfers. So I just wanted to measure 10 transfers. I probably don't need to measure 10 transfers. I can just do one. But anyway, we'll just let this one go. So 10 owner transfers. So that's like the owner of the fungible token contract transferred fungible tokens 10 times. They just said transfer, transfer, transfer. So basically, it spits out these things, and these console logs are coming from these parts in the code, like the cost. These get cost calls here. So it's just skipping to another line. And the final one was the total cost of a guest claiming a drop and then upgrading to their account. So what is that total cost? Well, it's about 0.0053, blah, 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 NEAR. Okay. So that's kind of like all you need to know. There's a profile sort of utility, you know, box, like a box of goodies, you know, things that you can use to profile stuff. It uses big number JS to do all of the addition and subtraction, because one NEAR token is like a 1 with like 24 zeros behind it. So, and then gas is typically measured on like a 1 with 12 zeros behind it. So these are very, very big integers, big numbers, but the way that we would read the number is we just want to know how many NEAR tokens it actually ends up being so that we can convert it to something. So for example, if I wanted to take this cost and convert it to something, I would just put it into, I typed calculator into Google. I would just do this times, you know, like let's say $5 NEAR token. So that's how much it costs. It costs 2 cents, 2.6 cents. So basically what this says to me or to some user or partner or somebody who wants to build on NEAR is that at $5 for a NEAR token and at the current gas prices, which of course, if NEAR tokens, you know, go way up and we do sharding and we do a bunch of stuff, this price of gas should go down. But right now, currently today on mainnet, it should only cost 2.6 cents to bring someone into your smart contract, have them register as a guest, have them claim a fungible token balance, and then upgrade them and basically send them on their way into an account, like a real account on mainnet where they can pay for their own gas. It does not account for any NEAR that you will give them to pay for their own gas, but it does count the upgrade process. So it's pretty cool. Like it's pretty cheap. So, and then the cost of 10 transfers from the owner was here. So 10 fungible token transfers, just as sort of a benchmark. That's kind of a useful metric. So I think I ran it 10 times just to make sure that there wasn't much of a difference. There's actually no difference whether you run one transfer and then multiply that by 10 or whether you run 10 transfers. I was just curious what would happen, you know? So let's say you times that by 1,000. So this is 10,000 fungible token transfers at a price of $5 per NEAR token would cost about $37. So we could basically have a decentralized exchange that had 10,000 fungible token transfers happening on NEAR, and we have our bridge now, so we can bring over bridge tokens. And if you can imagine, like a single fungible token transfer on Ethereum right now costs like $10, one transfer. And we're talking about doing 10,000 transfers for $37. This is like crazy. It's wild. Are you guys excited?
Hey. And we can even, I think, optimize it by using multi-sender or something like that. Because we can send, yeah.
Sorry, go ahead.
Yeah, I said that you send those 1,000 transactions one by one, yes, in turns. But we can I understand we can optimize it. And if somebody wants to send them, we can write some special smart contract, like a multi-sender smart contract, actually, which is already exists. So our customers will pay even less if they really will need to send 1,000 times some fungible tokens.
Yeah, that's a very good point, Vadim. So in my example here, I am making what's called like an airdrop or a token drop to a bunch of people that can claim it, right? But you make a really good point. I have done zero optimization. And so if you think about, let's just get the cost of, well, actually, no, like let's just keep it simple. If you think about the cost of just transferring, so somebody comes and they authenticate and they already have a NEAR account. So forget about all the guest stuff. They just have an account and they want a, so I'm just going to divide that by 0. So somebody comes to an app and they already have an account and they want to claim some sort of token drop, some airdrop, right? So it should only cost, to do the fungible token transfer part of the drop, it should cost 0.3 cents. So this is one fungible token drop on NEAR, and this uses our fungible token standard. It's 0.37 cents, 0.37 cents at $5 per NEAR token to send a fungible token. Now, this is a good point Vadim makes. This is without any optimization. This is literally like the dumbest, naive kind of way that you could send people tokens. It's just, you would have some server that is authenticating, oh, you know, this is the correct account or that claimed the drop. And now from the owner account with the balance that is giving out the drops, you know, send these tokens. And it would just send one at a time, just send, like transfer. Now, what do we know about making a transaction? We have overhead in creating the transaction and then completing the transaction and issuing, you know, receipts and things like that. But if we batched it, and if we said, okay, send to the next 10 people or 100 people, we could probably do a lot better. And we could also do an even more interesting kind of approach. We could have all the NEAR accounts come and claim against the smart contract using some sort of like, Merkle airdrop or something like that. So you can reverse it so that the owner doesn't have to actually send out, 10,000 drops, but you can have individual accounts each pay for their own claiming of the drop, and then the tokens are transferred. So they're paying their own gas. And that's what you typically do in Ethereum, because it's so expensive to send people tokens, especially a lot of people, like 10,000 transactions, that you actually have to flip the airdrop model and have the users who want to claim the drop pay the fee. So that's typically done by basically taking like, a Merkle tree of everyone's drop amount associated with their account. And then what people do is they come and they claim that their account ID and their drop amount or whatever is inside the Merkle tree. And then you work your way up to the root of the Merkle tree, because storage, you only store the root of the Merkle tree. So anyway, long story short, there's all these hoops and tricks and fancy things that you have to do in order to get fungible tokens out to a wide audience on Ethereum. But with NEAR, you could basically do, like, let's times this by 100,000. Oops. 100,000. So $374, 100,000 people with fungible tokens. And that's by sending the most naive, stupid transfers that you could do, just like transfer. But that's like, when you start thinking big apps, when you start thinking big, big growth, big user base, you start to scale out your numbers. And also, especially lifetime cost of using, a protocol like NEAR. So let's say NEAR tokens jumped up to be $50, theoretically, not financial advice. This is a complete hypothetical just for calculations of the cost. So you would jump up to like $3,000. But what I personally know about what the team will do is we'll come in here and we'll do something like, we'll reduce the gas cost by, let's say 1/2. So even still, it starts to look like affordable, right? Like it starts to look okay. 100,000 users. I want to give them all fungible tokens. I want to just send 100,000 times. It's going to cost like $1,700 over the lifetime of my app's growth. I mean, it's not that bad. Like it's not the worst thing that could happen to your app, that you now have 100,000 users who now have your token, right? Not that bad. It's pretty good. And that's assuming that NEAR is expensive and assuming a bunch of other things happen. But, just painting scenarios. I find this super helpful because when I'm talking to our partners that are building on NEAR, we have to communicate some sort of future reality for them where these things, cost a certain amount, or we can sort of assume that, even with the growth of the network and stuff, like things are going to grow at a particular rate, and you can never be too expensive or too cheap. Anyway, any questions? That's really all I wanted to show. Currently, by the way, this is in the Fungible Token Launcher repo, but I may just post like something like profile utils. I may just post this on like a GitHub gist or something and like make a comment about it. But I put it here because I had to deal with calculating this for a partner. Any questions?
I saw monitor of gas storage on last Sharif's presentation, which shows in like an online all the size of the storage. Am I right, Sharif?
That's a different piece, Vadim. So you're talking about the NEAR account utils. in the
yeah.
NEAR-examples organization. That's just sort of reading what's in storage. But what Matt is showing here is actually capturing the gas that's burned. There's also a gas profiling tool that Ilya posted about that's been recently released. I don't know if you saw that or if that's integrated here and I just missed that part.
I have not seen the gas profiling tool. I know that a lot of the gas profiling stuff is still really early.
Little rough. Yeah, a little rough around the edges, I heard as well. Yeah.
Yeah. So the closest thing I could get to is basically, well, I'll show you how this stuff works. Basically, the closest thing I could get to is, hang on one sec. Somehow I get the cost of, get cost per byte from test utils. Okay. So if you want to know what the cost per byte is, you have to basically make a call to the connection provider experimental protocol config. And basically you can pull out the protocol config, runtime configs, storage amount per byte. I'll show you what this looks like though. This is really helpful for some people who are learning about NEAR for the first time. So what does this object give you? Experimental protocol config. What is that? So experimental just means that it is an RPC endpoint that we're trying out. So we're gonna maybe make this part of the official RPC, but it's not official yet. So if you watch the first thing that happens here, you'll see that this pops out. So protocol version, Genesis time, chain ID, Genesis height, blah, blah, blah. What we're really looking for is the storage amount per byte, this thing right here. Okay. So that's what I pull out here. And why do I pull that out? Because when I go through and calculate, I'll just close that. When I go through and calculate get, burn, and storage, or get storage, I need to basically calculate the current storage usage with the previous storage usage. And then I need to multiply that by the cost per byte. So when I get the account state, I'll show you what that looks like. Let's print that out. Where is it? Oh, get account state. Of course it's in test utils. Why would it be in there? I'll probably have to just pull these over. These are really simple, like boilerplate kind of things. I'll just do an example one here. Or actually here, what I'll do is I'll just do, don't do this at home. It's bad. Bad variable names. Okay, so let's take a look at what that looks like. So you'll see some state of accounts being logged out here. So it'll just take a sec. Oh wait, promise pending. Yeah, that's gonna be the first one. Oh no, it's in. Yeah, it's here. Okay. So just give it a sec. Okay, so you see this. This is the, I'll just stop. This is the account state. So if you ever want to know about an account, like what is it doing, you'll see here, look, the storage usage. So that's measured in bytes. So why is the storage usage for like, I'm pretty sure this is the quote unquote like Bob or Alice account, or this is some other account, like the whatever. It's not the contract account, but you can see storage usage is like 1274, then it's 1547. So that's the amount of bytes. And then you jump down here to this this account that has more NEAR tokens, and it uses a lot more storage in terms of bytes. Why is it using much more storage? It's because there's a contract deployed. So that's what's kind of cool about this. You can tell. Oh, well, you can also tell there's a contract deployed because of this. So here's like the empty hash 11111. I think it's like 32 ones. Here's the code hash for the actual fungible token contract account. So anyway, long story short, that was just a way to kind of show. I'll just get out of this. Whoops. Yeah. Okay. we don't want to do any changes there. Long story short, that just shows you how to basically get the storage used in bytes, and then you need to multiply it by the cost per byte, and that gets you that. And then storage burn is really just taking the amount of NEAR tokens that the account has from before and after. But yeah, and that's actually going to be just burn. So why is that only burn and not why does the NEAR amount from before and after not include the storage amount? It's because storage in NEAR is rented, not actually the NEAR tokens for storage are not burnt, they're just rented. So basically your account still has the total amount of NEAR, but the storage amount is locked. So it's a question about whether or not the total NEAR amount is 100% available, which would mean that your account actually uses 0 storage. I don't even think it's possible for a named account because every named account uses some amount of bytes. That's the difference between an account that uses 0 storage. The amount will be equal to the available amount of NEAR that you could theoretically send to a friend. But if you use storage, the amount is not equal to the available amount, because the amount is the total amount of NEAR in the account, and the available amount is the total amount of NEAR in the account minus the NEAR that are locked up for storage. And of course, that storage amount is the storage used multiplied by the cost per byte of that storage. Sorry, that was like a long kind of technical explanation, but all you need to know is there's gas burnt and there's gas reserved for storage that you get back later if you release the storage. So actually, one kind of fun related note here is that I have a separate get storage method. And the reason why I want to get the storage of the contract after the guest upgrades is because we use the guest account to burn gas to upgrade the guest, but the contract itself releases storage in that process. So we used to have a guest record of like how many tokens the guest has, but then we delete the guest record when we upgrade the guest. So you actually get back the storage amount. So in terms of calculating my costs here, I'm going to just show you. I used to have this. I don't know where it went. I'm going to print out the total list of costs for this example. So you'll see the array of costs. One of the costs is negative, which is interesting. And why is it negative? Because the storage released will count against the total cost. So you'll see it go like burn, really big storage cost. And that's adding a guest record. And then it'll go burn, and then it'll say negative storage cost. And that's releasing the storage, the record for the guest. Let me just check this here. Yeah, so that's only going to run once. Okay, so let's do this. So now when we run through in the end, when we get the costs, the array of costs will have, small, large, small, maybe small, and then negative, large. And that's just because you're releasing that storage. So it's going through. So here's the cost that I'm tracking for the, so by the way, you can track multiple costs at the same time. So the default is just default. And then you can name an extra costs array if you want to do like if you want to profile separate like groups of costs. So here's the default group of costs, and it's sort of gas burnt, gas reserved for storage, or NEAR reserved for storage. I mean, it's kind of like a concept of gas. Gas burnt, gas paid for storage again. I can't remember why. And then gas released here. Can't remember why that happens again, but let me think here. Claim drop, Bob upgrades self to real account. Yeah, I don't know why there's two sort of rather large kind of spends here. And then there's one that it looks bigger, but it's not. It's just like a reclaim of one of these. So I don't know why that there's two of these. But it's here. And there's here. So 1, 2, and then there's claim the drop. Oh, I think it's all, oh yeah. Okay, I know why. The second large transaction is actually the gas that is burnt. It has nothing to, I mean, it does have to do with storage because the guest account is actually calling a method inside the contract that is going to have to pay for quite a bit of storage because it's calling create account. So that's where that measurement is actually measuring. So when I call get the burn, it's actually taking NEAR tokens from, I think it's the guest account, and it's basically going and sending it to the newly created account and then reserving the name. So basically that's kind of like a storage operation. So we're moving from like one kind of contract storage here where we're storing the guest account just in the contract, and then we're moving to the guest account being stored on the actual protocol itself. But now there's a newly created NEAR account. It just takes that name, and then the contract itself reclaims the record that it has. So it reclaims the storage that it had reserved for that guest name. So that's kind of what's going down. Anyway, that's about it. It's really not an exciting topic, but I wanted to cover it because
For sure it is. It's great.
you know, if you want to figure it out yourself, that's what's going down. How can we make it cooler? How can we make gas costs sexy?
CSS, more CSS.
Oh yeah, you mean come in here and style this?
A front end somehow. I mean, sure, we could colorize the terminal, but have some front end that captures this stuff.
No, we gotta go OG. First you colorize the terminal, then you make the front end.
Wait, but Matt, I think this would actually be a really cool thing to like do an example app with. Right?
Oh, like showing gas costs?
Yeah, and like creating like a little interface that people can use to calculate gas costs. Like an actual front end for it. I think she was onto something.
We could do that. We could just have it sort of, you know, do this transaction, do that transaction. Wait, Vadim, don't you have a cool front, like a cool server with a little front end going on? we could maybe add some sort of profiling to that.
Wait, but wouldn't it be cool if like we could like basically just be like, when we're telling people who are Ethereum native, right? Because everybody who's Ethereum native is kind of like on board with like how much ETH gas is, like they understand it. If we could just send them to like a demo app that's like, hey, do the exact same transaction you were going to do on ETH, to like plug in whatever, and like a calculator that then shows them exactly how much it would cost them on NEAR. Like this would actually be a really cool way to onboard ETH users, and a calculator that shows them like the difference between ETH to NEAR. Like we could even have like a savings calculator. Do you know what I mean?
Yeah. Oh, I closed that window. I did do the cost of a fungible token transfer here. Oh, it's not 10 owner transfers anymore. This is just the cost of one fungible token transfer. But I did do, so if you did 100,000 fungible token transfers on NEAR and NEAR cost $5, it would cost you $374. So that's 100,000 fungible token transfers. So
yeah, that's like wild. That's what I'm saying. It's like, what if we actually made like a front end web page or something like that, like a calculator where you could be like, okay, plug in your ETH transaction, and then we can tell you how much that would have cost you to do on NEAR.
Oops, sorry.
My
Discord.
Does that make sense?
Yeah,
like,
I'm really bad with sharing my screen. But yeah,
now you're sharing your Discord.
Yeah, my Discord's that's not that bad. What is it?
Okay.
People.
Ash, I think that
Yay!
I think that part that you're talking about is there's a bit of a disconnect, just because when you do a transaction on Ethereum, like, it's not quite clear what code is running unless you dig a little bit deeper. So you'd have to dig a little bit deeper. If it's a standard transaction, then what you're saying makes perfect sense. If it's like an NFT
Yeah, I
token
think we could
transferring or
start with
something like
standard
that.
transactions, and then if we wanted to, I mean, doesn't Block Explorer store all of the information? Am I wrong?
Mhm.
Like,
No,
it does?
you're absolutely right. Yeah,
What-
yeah.
If we wanted to, we could take that a step further past the standard transaction and just like have them link their Block Explorer link, and then we could run something that scrapes it basically. It's like, this is
Yeah,
just a
and
concept.
you wouldn't.
It's-
No, it makes perfect sense, but you wouldn't actually need to do much running, because once you do it once, and if it's a standard transaction, it's just a lookup table. It's like 2 columns in a spreadsheet. This transaction in Ethereum costs A, in NEAR it costs B, and you could just have a little tool that like looks that up. So I don't know, Matt, if that spoke to you, that example, but I think what Ash is saying is, imagine something, it's a Chrome plugin, it's a a bookmark utility, bookmarklet or whatever they call these things. You click a thing, and you just basically somewhere on Explorer, what do they call the Ethereum Explorer? It's called ETH Explorer. What's it called?
It's like
Etherscan.
Etherscan.
Etherscan, perfect. So you're on Etherscan looking at a transaction, you click a button in your Chrome plugin and it tells you how much it would cost for the transaction that you're looking at on NEAR. And if it's standard, ERC 20 transfer or something like that, then it's basically a lookup table, right?
Yeah, it's not hard. I mean, and then you just hook in with the CoinGecko API, which doesn't even require like a login, and you just say, yeah, in dollars, it's going to be this much.
Send you a link.
Yeah. So
I'm sorry.
Sorry, go ahead.
I just want to tell Alex Shevchenko did the research and he compared transaction fees for Ethereum and for NEAR, and he understood that NEAR is 2,400 cheaper. It's linked in the chat. When he compared Rainbow Bridge stats, costage for the same transaction on Ethereum side and on NEAR side. So 2,400.
That's to you, Ash. You see that?
Yeah.
And actually about what Ash is telling, I think our gas which is burned on transactions it's very good displayed on a Block Explorer now, because it shows every step, every single line explanation how gas was spent. If you click on any transaction, it's very clear now. So you can easily
Shows
send
that now?
Yes. Still, I will send you just a random link which is opened on my screen.
My Brave history, I worked at Harmony. My Brave history still pops up with the Explorer for Harmony because I worked there so much, and I kept visiting it because I was working on it. So bad. So my Brave history, need to purge that history. So let's look at this though. Wait a sec, Vadim, because one thing that's cool about testing against testnet using these Jest tests is that what are you talking about? Oh, because it's not testnet. One thing that's cool is that you can paste in these accounts and you can actually see the exact same stuff that I was calling. Nice. So you can see this kind of breakdown, right? So yeah, it's about what I'm measuring. It says 6.2 here, and then there's 2 tera gas burnt. Receipt ID, gas burned. So it's this 2.4 plus the 6.2. And what I get out, I didn't even know, by the way, Vadim, I didn't even know this. Isn't that bad? Like
yeah, it's quite recent. I think it came.
Yeah, this is just in the last couple of days, this thing.
But look, y'all, look, 7.4, right? So if you go back and you look at 2.4 plus this 6.2, you get about 8.6, right? So it's pretty close. It's not bad. To be honest though, I think these are rounded up like rather aggressively perhaps. And oh no, they're broken down pretty small. I don't know why would it show this and then the actual, because what I'm measuring is the actual differential of before and after the transfer. So why am I getting a
Maybe you're missing something. You're missing some of the resources that are consumed in, I don't know, do we count gas for like transfer of receipts or anything like that? Parsing the receipts, anything like that?
Sharif, I'm measuring the actual amount of NEAR that the RPC returns like from a before. All I'm doing is I'm marking the amount before and then checking the amount after.
Matt, can you scroll down? Scroll down.
Yeah.
Transfer is not the. It's something different, right?
This is a receipt. This is a receipt back, right? This is a refund, isn't it? Or no?
Yeah,
am I going crazy here? That's how much NEAR.
Yeah, but this is refund. Refund is too big to be considered.
Big, yeah. Weird. Okay, well. About 8 T-gas.
Okay, next time we have to ask somebody. We can ask to join somebody from wallet team to explain. Probably Vlad Frolov who did this.
Yeah, actually, by the way, I think I can explain this. So internally, there's many mechanisms that are going on, and from what I was told just this morning, the internal like profiling and measuring of like receipts, like so when receipts spit out like the estimation of the gas used, they're still fine-tuning this. So it may just be that they're a little bit sort of like pessimistic right now because they don't want people to sort of bank on having more gas than they think they have. And that may be it, but all I know is like, I mean, I'm measuring what RPC is telling me, NEAR before, NEAR after, and I'm doing things like many transactions in a row and measuring before and after, and I mean it's still popping out to be somewhat less than this. I'm not sure. I think maybe just the calculation of the receipt amounts is probably just not like super accurate at this point. For whatever reason, I don't know why. Or there's some weird aggregate value. Like so the calculation of receipts is perfect, but then once it leaves the calculation of receipts, which is like it should be perfect. Once it leaves and actually goes to like charge me, there may be some differential there that's not being accounted for. So who knows? I mean, that's a core protocol. Let's get those guys on a call. Let's clean this up, right, Sharif? Just joking. But Ash, that's a cool idea for an app.
Sorry, I was on mute. Yeah, I say clean it up or clean it out. Something like that. I don't know. Let's get those core protocol guys on a call. Anyways, I like your suggestion, Ash. I think it's good. But anyway, I'm gonna stop recording now so this video isn't like super long. But basically, that's the general idea. So you can check it out on Explorer if you want to check it out. But it just keep in mind it may be reporting a little higher than what the account is actually has before and after the transaction. I don't know why it's saying that, but actually wait 1 second. Oh, I know why. I know why. Maybe hang on. I'll stop recording in a sec if this doesn't work out. I'm gonna get the burn and storage, and the reason why is because that transaction may actually have been doing more than I thought it was doing. So I may have to measure the storage used to change the balance of the Bob account. No, it's still popping out as 0.00075. Weird. Okay, that's weird stuff. Let's go look at
Let's go look at the account once again. Oh, wait, guest ID. Oh, I'm looking at the wrong account. Here it is. This is the guest account. Hang on one sec. Wait, but that no, that account's not doing anything. It's really the account that it's calling is doing stuff. But the guest account is spending the gas. It's really weird. Anyway, I'll do some digging and try to figure out where I have a discrepancy here. I think that it is like I've been told that the receipt stuff is like not perfect, but that could be something else. Anyway, that's it. If you want to profile gas, check out this repo if you want to profile gas as I have been doing against testnet. And you know, there could be some changes coming, but I personally think that measuring account NEAR available, you know, or total NEAR before and after is a good way to check the burn. It's into the NEAR-apps repo /FTLauncher or FT-launcher. And it's in the test folder here. So it's under profile.test.js and there's profile utils. That this is all sort of a very much work in progress. So if you want to just grab it now and just try to add it to your project, you can, or you can wait for like an update video in a bit when we make that cool app. All right, I'm going to stop sharing. How do I? Going to stop recording.